Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. And as I said, I'm going to start posting multiple videos every day so that we can complete the course before the Regents. Today, I want to go over sequences and series. We have two types of sequences and series, which are the arithmetic and geometric. So I hope to finish the arithmetic today, and then next session we'll do the geometric. So what is a sequence? A sequence is a bunch of numbers that have some relationship. If it's arithmetic sequence, then we get the following: arithmetic sequence. We'll have some numbers. We are going to call them a sub 1, the first term, a sub 2, and so on and so forth. Can I pick any numbers? No. You pick them in such a way that the difference between each number, so a2 minus a1 is the same as a3 minus a2, and it's a common difference. We refer to it as d. So we can rewrite this as a1 plus d, a1 plus 2d, until the last one would be a1 plus n minus 1 times d. Why n minus 1? Because the first one was a1. The second, we added just a single d. The third, we added 2d. So the nth, we add n minus 1d. So for example, I can say the first element is 6. The next is 10. Oh, the difference is 4. So I keep going. 14, 18, 22, and so on and so forth. Or I can start with -7 and then -9. And then, oh, that decreased. Yeah, it decreased by 2 every time. And so on and so forth. So here D is 4 and A1 is 6. Here D is -2 and AY is -7. So now, given me these two pieces of information, what is the first element or term, and what is the difference? You can ask me to find the 100th term or the 718th term, right? It's so easy. And we call that a sequence. It's as simple as that. Sometimes we give you the sequence explicitly. What do I mean by explicitly? For example, for this sequence, I can say this sequence S is, you can get it by saying 6 plus 4 times n minus 1. 6 is the first term, and then you keep adding, I'm sorry, plus 4n. Why did I say 4n minus 1? Six plus 4 times n. Yeah, n minus 1 because I'm adding, it was correct. 6 is the first term, and then when you make n equals 2 to get the second, you would say 4 times 2 minus 1. 2 minus 1 is 1, plus 4 is 10. What about the third? 6 plus 4 times 3 minus 1. 3 minus 1 is 2. So 4 times 2 is 8, and the 6 is 14. Notice that I can also distribute the 4, and I get 4n plus 2. And that would be it. So the first term is 4 plus 2. The second term is 8 plus 2, 12 plus 2, and so on and so forth. And that would be an explicit form. Either I give you this piece of information, or I give you this equation, this or that, and you can find out any term. However, I can give you also an implicit information. I can tell you, for example, S1 is 6. Oops. And then after that, S sub n is S sub n minus 1 plus 4. What? Yeah. S1 meaning the first term, I called it S, but some people think of S as the sum, meaning the series. But just for maybe here I just want to find the A sub n. So let's call it A sub 1, like here, and this is A sub n. And this is A sub n minus 1. So I give you the first element, which is 6. And then I tell you every term in this sequence is 4 more than the previous one. Huh, that's an interesting way of saying it, but it's a correct way. Because if I know A1, then A2, if n is 2, A sub 2 equals A sub 2 minus 1, which is A sub 1, which is 6 plus 4. A sub 3 is A sub 2 that we just found as 10 plus 4, and so on and so forth. And that's all what we need to say about um, sequences, that I can write it A sub n. So I can write it explicitly or as a recursive equation. Give me the previous one and tell me how much this one is bigger. So it's like, I'm lazy. Just tell me what is the previous one, and then I'm going to add 4 to that, right? And now also remember that this guy right here is another equation that we use. So we say A sub n equals A sub 1 plus n minus 1 times d. And that's really all what we need to know in sequences, in arithmetic sequence. Now let's go to the series. What is a series? The series is the sum of n terms of a sequence. Suppose I give you these 4 elements and I tell you, can you find the sum of these 4? Yeah, I have a calculator. So 6 plus 10 is 16, and 16 plus 14 is 30, and 30 plus 18 is 48. The answer is 48. Say, very good, you are so clever. Okay, now give me the first 125 terms. You say, what? How can I do that? Yeah, you see, you were not clever after all, right? You tried to trick me and add them up. And it turns out that the sum can be written as follows. A sub 1, the first term, plus the last term divided by 2, meaning you are taking the average of these and multiply them by n. Some people would say, I can combine these two. So instead of A sub n, I can write that. Yeah, you can. You can. But why make it so hard? If I know the first term and I know the last term and I know how many terms, I would find it. But suppose I don't know the last term, I would say, okay, you want 125 terms, okay? So A sub 125, oh, I have this equation here, equals A sub 1, which is 6, plus 125 minus 1, which is 124 times 4. Multiply these, you get 496. You add 6, you get 502. So the 125th element is 502. I found it very quickly. Okay. Then I would say the sum of these 125 terms are 6 plus 502 over 2 times 125. This is 508. When you divide 508 by 2, you get 254, and you multiply that by 125. And then you use your calculator and say 254 times 125 equals 31,750 is the answer. Easy, right? Now, I mentioned before in one of the videos about um, young Gauss. Mr. Gauss, when he was in elementary school, he was in class, and the class were making like a lot of noise. So their teacher became so angry at them, and he said, "You know, I want each one of you to write the numbers 1 through 100 and add them up." He wanted to get some, punish them and at the same time get some quiet time. Like, so he stayed there and then doing whatever he was doing. And a little later, he looked and Mr. Gauss was sitting down and he said, "Sir, come here." And young Gauss came and he said, "Yes, sir. What do you want?" He said, "Didn't I say you count the first 100 numbers, 100 digits, and you add 1 plus 2 till 100?" And he said, "Yes, sir." So he said, "Why are you sitting crossing your arms like you don't have anything to do?" He said, "Because I don't, sir. I already finished." "Oh, yes," Bart asked. "Okay, sorry. Come and show us then." He said, "Okay, sir." I started writing 1 plus 2 plus 3. And then I said, "Oh, at the end, I will have 98 plus 99 plus 100. And then I said, what if I write them backwards? So I write 100 plus 99 plus 98. And at the end, I have 3 plus 2 plus 1. I found that each one of these two equals 101 plus 101 plus 101. How many of them? 100. So I said the answer must be 101 times 100. And then I remember, oh, I doubled them. I counted them twice. So I divided by 2 and got 50/50 is the answer. Do you see that A1 was 1? A sub n was 100. So if you add the first plus the last, you divide by 2 and multiply by the number of terms, you get the same exact thing as young Gauss found as an elementary school student. So now you don't have any excuse not to nail it down. Sorry, we are going to be sent back to elementary school if we fail to do that. Okay, leaving funny dad jokes away, uh, let's go back and look at some of these problems, practice problems. Maybe we'll do 4 of them, maybe the odd numbers, because I still have to do 4 more for series, and these should be easy. See how easy it is. So let's do number 2. A sub 1 equals 3. What is the difference? The difference, you take any, not the first one, any term and subtract the one prior to it. And just to make sure it's arithmetic, not geometric, which we will cover next time, you do 2 of them. So you say -2 minus 3 is -5. -7 minus -2 is also -5. Yeah, that's arithmetic. If you get a different number, maybe it's geometric. We'll talk about that next time. So now if I want a sub 36, I say it's a sub 1 plus n minus 1, 36 minus 1 times 5. A sub 1, of course, is 3. So 3 plus 35 times 5. 35 times 5 is 175, plus 3 is 178. Let's take one right, one left. Okay, this guy. They already gave me a sub 2, not a sub 1. Okay? And D. So I can get a sub 1 if I want, or I can develop my own function and solve right away. We don't want to do that. We say a sub 2 equals a sub 1 plus D. A sub 2 is 16. A sub 1 is what am I looking for? -9. And then I'm going to add 9 to both sides. So I get a sub 1 equals 25. Easy? So a sub 21, I'm sorry, a sub 21 equals a sub 1 plus n minus 1 which is 20, times negative 9 equals 25 minus 180 equals negative 155. Let's move to the next one. They give me a sub 9. Notice that if I subtract 8 from the subscript, meaning this one, I could have said if a sub 2 is 16, and I want a sub 21, it's the same thing as say, oh, a sub 1 is 16, and I want a sub 20. And I would have solved for a sub 20 instead of, I don't want you to get confused, but really it boils down to that. I could have said a sub 1 is 16, so a sub 20 equals a sub 1 plus 19, not 20, because 20 minus 1, 19 times negative 9. Negative 9 times 19 is negative 171. And when you add 15 to that, meaning you subtract it but make it negative, you get negative 155, which is the same answer. Same thing here. They give me a sub 9. They give me a sub 9 and they want a sub 35. This is exactly the same as if they gave me a sub 1, 8 below, and they want a sub 27, 8 below. So even though I'm not looking for a sub 27, but if I assume, that this is a sub 1, I can solve it. So I can say a sub 27, but in the answer, of course, I would write a sub 35, which equals a sub 1, which is negative 60 in this case, plus 26 times negative 10, and minus 1. So that would be negative 60 minus 260 equals negative 320. Someone else would say, no, I want to do it. I don't trust you. You always put us in hard time, give us hard time and put us in a wicked situation. So I'm going to say, okay, a sub 9 equals a sub 1 plus n minus 1, which is 8d. A sub 9 is negative 60. A sub 1 is unknown. D is negative 10, so minus 80. I add 80 to both sides and get A1 equals 140. And then solve the original problem. A sub 35 equals 140 plus 34, which is n minus 1, times negative 10. So it's 140. Oh my God. I did. Wait a second. They give me A sub 1 is 20. What did I do here? Right? A sub 1, I add 80 to both sides. I can do math even. So this is 20. So this is 20. 20 minus 340 equals negative 320. So no matter what you do, you will get the, but this is easier, right? It's less work. Let's do we did the one on the right, so let's do the one on the left. They give me a sub 12. So I'm gonna say subtract 11. So I say a sub 1 is negative 73. And instead of a sub 20, oh, they give me these two. Okay. Yeah, I'm sorry. I wanted to say that. A sub 1 is, it's as if I say a sub 1 is negative 73. I subtracted 11. So here I subtract 11. I say an A24 is negative 280. And from these, I can find the D because I'm going to say a sub 24, which is negative 280, equals a sub 1, which is negative 73, plus 23D. I'm going to add 73 to both sides. And I get 23D equals negative 207. And then I'm going to divide by 23 both sides. and I get D equals -9. And now I have A sub 1. We assume A sub 1 is 73, but we subtracted 11. So I'm going to subtract 11 and say, so what is A 17? Because A sub 17 now would be A sub 28 in the original sequence. So A 17 would equal A sub 1, uh, A sub 1, which is -73, plus 16 times -9. 16 times -9 is -144. And this minus that should be -217. Can we do it slightly different? Absolutely. Well, we already have this page here. Otherwise, if I say if you don't want to do that, A sub 35 is -280 and A 12 is -73. Okay? I can write two equations in two unknowns. I would say -280 equals A sub 1, which I don't know, plus 34D, which I don't know. A sub 12, which is -73, equals A sub 1, which I don't know, plus 11D, which I don't know. But now you can see that with elimination, if I subtract the bottom from the top, I will get -207, these cancel, and those two will give me 23D, and the rest is history. So you have two ways to do it, and really it's up to you to decide how to do it. This one is a little long, but this is what your teacher wants to see, because he didn't tell you this is A sub 1. No, this is A sub 12. So why did you use it as A sub 1? Because it didn't matter. If I want to go, 4 terms to the right from here or 17 from there, it's the same if you account for that. Anyway, I hope that I didn't confuse you here, but you have two ways to do it. So these were about finding like a specific term. But what if I want you to find a series? This one is the one that is working. What is the sum of the first 19 terms of this sequence? As I said, to reduce the number of equations and rules and laws that you need to memorize, it's easier just to find the 19th term from here and say A sub 19 equals A sub 1, which is 3, plus 19 minus 1 times D. But what is D? 10 minus 3 is 7. 17 minus 10 is 7. And also, so times 7. 7 times 18 is 126, plus 3 is 129. And now, like we learned before, the sum of the first 19 terms, A sub 1 plus A sub 19, A sub n over 2 times 19 equals 132 times 19 over 2. 66 times 19, 1304? No. Sorry. 114. It should be 1254, I think. Yeah, 1254, which is 3. Okay, let's move to the next one. Determine the sum of the first 20 terms. N is 20. of the sequence whose first five terms, so this is a sub 1 and d is 9. 9, 9, 9, 9. Okay, so the sum equals, the first is 5, I need the ninth, so the 20th. A sub 20 equals a sub 1, which is 5, plus 19 times 9. We said this is 171, so this is 176. 5 plus 176 over 2 times 20. 20 over 2 is 10. And this is 181 times 10 is 1810. See, it's pretty straightforward, very easy. An auditorium has 21 rows of seats. The first row has 18, and each succeeding row has 2 more. So 18, 20, then the previous row. Now, this is like the like when we give you two equations and we tell you, remember when we said it's like a recursive equation? A sub n equals a sub n minus 1 plus 2. So we can think of it as that. Okay, how many seats are in the auditorium? Nice. So there are 21 rows. This is the first, second. So we need to find the 21st row. How many seats are there? Of course, since you are, so you can say a sub 21 equals a sub 1, which is 18, plus 21 minus 1 and minus 1 times the difference, which is 2. This is 40. This is 58 seats in the last row. So now altogether, the sum of these 21 would be the first plus the last over 2 times 21, which is the number of rows. These are 76 over 2. It's 38 times 21, 798. Right? Yeah, 4. 18 plus 58 over 2 times 21. Yeah, 798. I knew it, but just to be on the safe side, sometimes I do crazy stuff because I don't know how to do math. In a theater with 30 rows, so n is 30, the number of seats in a row increases by 2. Well, this is the same thing. Increases by 2. So D is 2. So they give me D. The front row has 15. This is weird. It's the same problem. Why do they give it twice? Find the total seating capacity. That's really bad. A sub 30 equals A sub 1 plus 30 minus 1 times 2, 58. 58 meaning this is 73. Right? Okay, so the sum of the 30 are A sub 1 plus A sub 30 over 2 times 30. These two add up to 88. Over 2, it's 44 times 30, so it's 1320. Oh, 1320 seats. We can do the math. First of all, we can say 15 plus 29 times 2, that's 73. Then we say 73 plus 15 over 2, and we said 30 rows, 1320 seats, just to make sure I don't give you something wrong. And that's basically it for arithmetic sequences and series. And next time we'll do the geometric sequences and series to get done with that, and then we move to trig. In fact, if you if you are in a hurry, I already give in the trig and in the trig playlist, I have like 6 or 7 videos that, cover more than what you need really for. I will do them here, but if you are done with that and if you need help with trig, you can check there. And then that leaves us with, oh my God, we still have probability and statistics as well as uh, trig functions transformation. Oh my God. Okay, so I will see that, if I can post more videos. Okay, anyway, uh, if you have any questions, please let me know. If not, then I hope to see you tomorrow. Thanks for watching and have a great day. Bye.